The Fermi Paradox, where are all the aliens? Section A, Introduction. Have you ever looked up at the night sky and wondered, are we really alone in the universe? Given the staggering number of stars, over 100 billion in our galaxy alone, each potentially with planets in their habitable zones, it's statistically very likely that life exists out there. And yet, silence. We have no confirmed evidence of alien civilizations. No signals. No spacecraft. Nothing. This mystery is known as the Fermi Paradox, named after physicist Enrico Fermi, who asked the famous question during a casual conversation in the 1950s. Where is everybody? Section B, the staggering numbers. Let's consider the scale. Our galaxy, the Milky Way, is home to over 100 billion stars, and many of them have planetary systems. In fact, NASA estimates there could be 40 billion Earth-like planets just in our galaxy. Now, if only a tiny fraction of those developed life, and if only a tiny fraction of that life became intelligent, we should be seeing some signs of their existence by now. Statistically speaking, the universe should be teeming with life. So again, where is everybody? Section C, is intelligence rare? Perhaps intelligent and technological life is extraordinarily rare. When we ask, where is everybody, we're not just referring to simple life forms like bacteria or algae, or even more complex organisms with basic intelligence. We're talking about intelligent beings, civilizations capable of communication or space travel. Here on Earth, life has existed for more than 3.5 billion years, but only recently, perhaps in the last 200,000 years, have humans developed advanced intelligence and technology. So maybe intelligence isn't inevitable. It might have been a cosmic accident. Think about it, dogs are intelligent and emotional creatures. They can solve problems, learn commands, and show empathy. But they haven't built radio telescopes. Nor have they explored space. So, is intelligence destined to evolve toward technology? Or are we, humans, just an evolutionary fluke? That said, let's reflect. If dogs have lived alongside humans for thousands of years, why haven't we seen signs of more complex intelligence developing in them? Shouldn't it be easier, considering they live with a highly evolved species, and yes, we are animals too? In nature, many other animals also show a certain degree of basic intelligence. But we don't observe in them any advanced progression that might, even in the near future, bring them closer to our level. Will any of them ever get there? Maybe only time, and probably a very long time, will be able to answer that. Section D, the Great Filter. This brings us to one of the most chilling ideas in the Fermi Paradox. The possibility of a great filter. The great filter is a theoretical barrier that prevents life from advancing to the level of interstellar civilization. It could be behind us, meaning we've already passed a rare hurdle, such as the origin of life, multicellular complexity, or intelligence. But if the great filter is ahead of us, it means that every intelligent civilization eventually destroys itself through war, resource depletion, artificial intelligence gone wrong, or something we haven't yet imagined. And that would mean our future might be just as silent as the stars above us. Section E. Are we hiding without knowing it? Sometimes, the silence of the cosmos might not mean no one's out there, but rather that we're simply not looking in the right way. Just consider this, a civilization 10,000 years ahead of us may not use radio waves at all. Their technologies could operate on quantum communication, neutrino signaling, or even methods we can't yet imagine. It's like trying to pick up a Wi-Fi signal using a stone. And historically, we've already misunderstood cosmic signals before. In the 1960s, the first pulsars were so regular that astronomers briefly dubbed them LGM, short for Little Green Men. What if we're surrounded by signals, but they're buried in noise we haven't learned to decode yet? There's also the possibility that they don't want to be found. Some theories suggest that advanced civilizations might intentionally go silent to avoid being detected, either for safety or for ethical reasons. One chilling idea, made popular by Liu Cixin's The Dark Forest, imagines a universe where every civilization hides, fearing that revealing their location could lead to their destruction. As a terrestrial example, we can look to the arrival of European colonizers in the Americas, which led to the shocking extermination of much of the native population. And who's to say something similar couldn't happen on a planetary scale? A more advanced civilization could overpower, dominate, enslave, or even exterminate those less developed. On the other hand, maybe they would come in peace. Perhaps they simply seek to exchange knowledge, explore the cosmos, meet others, and help intelligent life wherever it exists. So, maybe we're not alone. Maybe we're all just whispering. Section F: we're early, or very late. Another theory? Maybe we are among the first civilizations to emerge. The universe is about 13.8 billion years old. Our civilization only started developing technology a few hundred years ago. Maybe we're just early bloomers in a cosmic timeline. Or, maybe we're late arrivals. Perhaps ancient civilizations existed millions or even billions of years ago, but they've already vanished due to natural disasters, internal collapse, or self-destruction. If that's the case, we might be seeing the aftermath of a universe where civilizations burn brightly and then disappear. Section G: they're out there, but invisible to us. Another possibility is that extraterrestrials are out there, but we simply can't recognize them. What if they're so different from us biologically, technologically, or dimensionally that we wouldn't even know what to look for? Maybe they're using communication methods beyond radio waves. Or perhaps they exist in forms non-physical, like artificial intelligence or digital consciousness. They could be observing us silently, following a prime directive of non-interference. And there's also the zoo hypothesis. We're like animals in a cosmic zoo. They're watching us, but not interacting. Section H: the speed of light and the weight of distance. One of the greatest challenges in the search for extraterrestrial civilizations is the sheer scale of space and the universal speed limit that governs it, the speed of light. Even if a civilization sent a signal from a planet 1,000 light-years away, we'd only be receiving it today if it was sent during the Middle Ages. And if we reply? Another 1,000 years for the message to get back. Now imagine traveling those distances. With our current technology, even the closest star system, Proxima Centauri, would take tens of thousands of years to reach. To make such a journey feasible, a civilization would need to build massive, self-sustaining ships, essentially small, traveling worlds. These so-called generation ships would house entire communities living and dying over centuries, all in pursuit of a distant destination. But what if they've already moved beyond these constraints? Some theorists propose that highly advanced civilizations might have developed ways to manipulate spacetime itself. Wormholes that fold space like paper. Warp drives that compress the fabric of the universe ahead of them. Dimensional travel, where moving through alternate realities might bypass the need for distance altogether. These ideas may sound like science fiction, but they're being seriously considered by some physicists today. In a universe governed by strange and unknown laws, what seems impossible now may eventually become inevitable. But there are also other possibilities. One of them is cryonics, the idea of freezing a person to survive long journeys across the cosmos. This technique, still in development, aims to preserve the human body at extremely low temperatures, with the hope that future technology will allow for revival and treatment. Another alternative is sending robotic probes, or even spacecraft crewed by self-repairing robots that can fix one another and possibly replicate themselves during the journey. Starting in 2017, astronomy began tracking interstellar objects, bodies whose speed and angle of approach to the Sun indicate they came from outside our solar system. The first confirmed interstellar visitor was Oumuamua, discovered in 2017. Its unusual trajectory and properties puzzled scientists, sparking speculation that it might even be of artificial origin. Then, in 2019, came the discovery of Comet Borisov, officially named 2I/Borisov, the second known interstellar object. Unlike Oumuamua, Borisov behaved more like a typical comet, though it too originated from beyond our solar neighborhood. More recently, astronomers detected a third interstellar object entering the solar system, 3I/Atlas. Initially classified as a comet, its behavior has raised new speculation about the possibility of alien engineering. At the time we were editing this video, there was still no definitive conclusion about its true nature or composition. Section I. The Journey in Time, the Loneliness of Light. Imagine we've achieved the impossible, building a spacecraft capable of traveling at 99.99% the speed of light. Now picture two cosmic journeys. 1. Nearby destination, Proxima Centauri. It's the closest star to our solar system, just 4.24 light-years from Earth. At 99.99% the speed of light. To someone on Earth, the journey would take just over 4 years. But to the crew aboard the ship, time would pass very differently. Thanks to Einstein's time dilation, the journey would seem to last only about 22 days. In other words, they would hardly age. 2. Extreme destination, the Andromeda Galaxy. Now let's go much farther. What if the destination were the Andromeda Galaxy, about 2.5 million light-years from Earth? On Earth, this journey would take 2.5 million years. But inside the ship, the journey would last about 35,000 years. An interstellar epoch only possible through successive generations or through cryogenics, the controlled suspension of life, awaiting awakening in Andromeda. Section J. We haven't looked enough. Could the silence just be a lack of data? The truth is, we've only searched a tiny fraction of the sky with our current tools. Our telescopes and antennas are limited. Our methods are primitive compared to what might be needed. It's like dipping a cup into the ocean and concluding there are no whales, because the cup came up empty. Maybe they're sending signals, but we're not tuned to the right frequency, or we're just not listening long enough. The universe is vast, and our attention span is short. Section K. The paradox remains. So where are they? Maybe life is rare. Maybe intelligence is rare. Maybe intelligent life destroys itself. Or maybe they're everywhere, and we just don't recognize the signs. The Fermi Paradox doesn't give us a single answer, it gives us a profound question. And perhaps the silence we hear from the stars isn't just absence. It's an invitation to explore, to imagine, to look deeper, and to understand not only the universe, but our place within it. If you enjoyed this video, leave a like, comment, share, and subscribe.